Hello, this is Vinay. I've been working as a ETL tester in from past 6 years. My career started with software testing and later moved on into automation testing using QTP tool. And later I'm currently working as ETL tester in from past 3 years. And BT teaching experience around 3 years and been teaching for various students and different parts of the world. And currently let's be discussing about the ETL testing and this is the course content for the ETL testing and this is what the requirement the duration of the course will be 30 hours and it's like 1 hour a day, it's like 30 days and online medium, the medium will be the GoToMeeting, Skype or the Gmail. The prerequisite for the ETL testing is SQL basics and the objective of the course is understanding the concept of data warehousing, ability to design and develop complex mappings, configuring workflows as in real-time environment, troubleshooting errors and failures, gain hands-on experience on multiple access and the real-time scenarios and a demo project, build confidence to excel your career as an efficient ETL tester. Course content. The main course content will be is like introduction to data warehouse, where we will be discussing like introduction to data warehouse and why, what, where and where we use in the data warehousing. The star schemas like star schema and snowflake schema, dimensions and fact tables, slowly changing dimensions and types of slowly changing dimensions. And moving on, the basic ones, basic level of ETL is like introduction to Informatica Power Center tool. I'll be showing practically in my lappy the Informatica tool and what the options available and how it looks like and how what operations will be carried out in Informatica tool. And extraction, transformation and loading process and Power Center tools like a repository manager, designer, workflow manager and workflow monitor. These are the different types of tools available in Power Center. And the source and target definitions, transformation concept like types, classification and basic uses, ODBC and relational connections. Okay, moving on, we'll be going into the basic UTL, working with flat files. How do we load data from flat files into the data warehouse and from data warehouse to flat files? Working with XML files, transformations, and there are different types of transformations in Informatica tool. It's like filter transformation, router transformation, sequence generator transformation, rank transformation, sorter transformation, joiner transformation, linear transformation, source qualifier transformation, expression transformation, aggregated transformation, lookup with connected and unconnected mode transformation, normalization transformation, stored procedure with connected and unconnected mode, update strategy transformation, transaction control transformation, Java transformation, SQL transformation, query and script wide transformation, SQL parser and SQL generator. These are the different types of transformations available in the Informatica, and we will be discussing brief, everything in detail in the class. And advanced ETL, different types of load types available in using Informatica, and slowly changing dimensions like type 1, type 2 and type 3. Indirect method for loading the data from source tables and target tables, and ETL test cases, writing the test cases, how do we write the test cases in real time and for different transformations. And these are basic the course contents of the ETL testing course. And moving on, we'll be going and discuss about brief description of the basics of data warehouse. What is a data warehouse? Why do we use a data warehouse? And what is the purpose of the data warehouse? Data warehouse is it's also a database, but it's used only for decision making and analysis purpose. It's not a storage transactional database. It's not relational, but it's not a transactional database. It's used for decision making purpose. Definition for a data warehouse. The data warehouse is a subject-oriented, integrated, non-volatile, time-variant collection of data in support of management decisions. So it's clearly describes that it's only meant for decision making. Okay. Integrated. See, we'll be having different types of databases which are located at different parts of the locations, and this is a sales database which is located in Hyderabad, and sales database which is located in Chennai. We'll be loading these two extracting the data from these two databases which are located in different parts of the country, and loading the data into the Informatica staging area, and we'll be analyzing this data and loading the data into the data warehouse. This is called integrated. We are integrating the data from different sources and loading into the data warehouse. Next is non-volatile. Non-volatile is like operational databases is like In automation data, we are able to insert the data, delete the data, or change the data, or replace the data. Whereas in data warehouse, it's not possible to delete or anything. It's only read-only purpose. It's only once the data is loaded into the data warehouse, there is no chance of editing the data in the data available, which is available in the data warehouse. It's only read-only. We'll be using only for analysis purpose. Okay. Next one, subject-oriented. Data warehouse is subject-oriented. This one, data warehouse is subject-oriented database which support business needs of individual departments in enterprise. For example, sales, HR, accounts, and there are different types of data marts which are used in data marts. Each one is called as a data marts, which we will be discussing in the coming slides. What is data mart? And so subject-oriented is completely subject-oriented. Okay. Next, time variant. The operational databases will be having only storing the data up to 60 to 90 days. We will not be storing the historical data. Data warehouses are used to store the historical data. It will be storing to 5 to 10 years. The best example for this is for operational databases. It's when you go into the ATM center, when we type for mini statement, we will be getting only the past 5 to 6 transactions. It's not possible to get the 1 year statement in the ATM center. That's best example for operating system. Whereas the example for data warehouse is when we go into the online and when we open ICICI bank account, for example, and go into the account statements, when we click the account statement, we will be getting past 1 year transactions in a statement. So that is where we will be getting data from data warehouse. That's the difference between the operational databases and data warehouse. Okay. Data warehouse is a database which is specifically designed for analysis of business but not for business transaction processing. It's only analysis. It's only used for analysis purposes, not for transaction purpose. Okay. Difference between OLTP and data warehouse. OLTP, it is designed to support operational monitoring. It is designed to support decision making processes. Okay. Data is volatile. Data is non-volatile. Okay. It stores current data. It stores historical data. And moving on, it stores detailed data. It stores summarized data. Operational system will do normalization data, and data warehouse will be showing as denormalized data. Relatively smaller database, whereas data warehouse are a large database. It's like huge terabytes of data, and size of data will be stored in the data warehouse. Designed to support ER modeling, designed to support decision modeling. Okay, moving on. Data warehouse architecture. Data warehouse architecture is like it will having the sources, different types of sources like Oracle database, SQL database, and flat files. Everything will be coming to the source. We'll be loading the data into the staging area of Informatica and loading the data into the data warehouse. After analysis, we will be storing the data into the data warehouse, where the data will be stored in different data marts. Okay. Sorry. Moving on, from data warehouse, we will be using the data for reporting purpose. They ask that is the architecture of data warehouse. The same picture. It's source systems using Informatica will be loading the data into the data warehouse, and after storing the data into data, we will be using for end users and reporting purpose. Data acquisition is a process of extracting relevant business information, transforming the data into required business format, and loading it in the data warehouse. It is defined with the following processes: data extraction, data transformation, data loading. What is ETL? ETL stands for extraction, transformation, and loading. The process of updating the data warehouse. ETL is automated and auditable data acquisition process from source system that involves one or more of process of data extraction, data transportation, data transformation, data consolidation, data integration, data loading, and data cleansing. Okay. Need for ETL. The process of ETL is required so that data from different heterogeneous can be stored, can be converted and brought into one common source. The main advantage of the ETL. See, we will be getting data from flat files. We will be having data from XML files. Will be some data sources will be having from Oracle database. Some data sources will be SQL database. So we are able to get the data and combine them into one location and getting the data from different heterogeneous sources and storing into the one database. That's the main advantage of the ETL. So moving on. This process, the ETL process is the source system and extracting the data, transforming the data in the staging area, and loading data into the data warehouse. Data extraction. Data extraction is the process of reading data from various types of sources such as XML relational sources, XML files, mainframe files, flat files. Okay, example for relational is Oracle, SQL Server, ERP, SAP and PeopleSoft, mainframe, COBOL files and DB2 files like flat files, XML files and text files. Okay, and moving on. Data transformation. Data is the process of cleaning the data and transforming the data into a required business form. The following data transformation will take place in staging error: data merging, data cleansing, data clubbing, and data aggregation. Data merging is the process of combining data from multiple inputs and loading into a single output. There are two types of data merging activities: join and union. By using join, we will be combining the data from two tables and into loading into that one table. We'll be discussing all of this in detail in the course. And data cleansing is the process of removing unwanted data from staging. It's the process of changing inconsistent and inaccuracies. Init cap, and these are the example for init cap, and round functions are the example for data cleansing. Data scrubbing, it is the process of deriving new definition data using existing data. The calculating of first name and last name and making it as a name of the employee or customer. Okay, data aggregation is the process of calculating summaries or group of records using aggregate functions: average, max, min. That's the process example for the data aggregation. Data loading is the process of inserting data into a target system. There are two types of data loads: initial or full load, incremental or delta load. Initial or full load, it's the process of loading all required data at very first load. Incremental or delta load, it's the process of loading only new records after initial load. Okay, incremental, and those are the two types of data loading process. Data marts. Data mart is a simple form of data warehouse that is focused on single objective or functional areas such as sales data mart, finance data mart, or marketing data mart. Data marts are often built and controlled by single department within an organization. There are two types of data marts: dependent data marts, independent data marts. Dependent data marts, according to WH in one, first we need to design an enterprise data warehouse, then a small form of subject-oriented department design specific data marts known as data marts. This is a pictorial representation of top-down approach. We will be loading data from different flat files and loading into the data warehouse. Later we will be creating data marts: marketing data mart, sales data mart, and finance data marts. Okay. Next one is bottom-up approach. According to Ram Kimball, first we need to design department-specific database known as data marts, then integrate all data marts into enterprise data mart. This is a bottom-up approach of pictorial representation of bottom-up approach. Loading the data from different operational different systems and creating them in the data marts and loading all data marts into the data warehouse. This is a bottom-up approach. Okay. Moving on, what is the difference between data mart and data warehouse? Data mart property, data warehouse, and data mart. Property: scope. Scope of the data warehouse is enterprise. Scope for data mart is department. Scope: subjectives. Subjectives data warehouse is multiple. Data mart is single subject. Data source: many. Data mart is few. Implementation time: months to years. Data marts: months. Okay. Data warehouse dimensional modeling. Dimension tables. Dimension tables contain textual information that reference the attributes of business. Contains relatively static data. Dimension tables are joined to fact tables through foreign key reference. Okay. Dimension tables examples: so retail, which contains store name, zip code, product name, and product category, day of the week. Telecommunication: call origin, call destination. Banking: customer name, customer number, branch, account officer. Insurance: policy type, insurance part. Fact table contains numerical metrics of the business, can hold large numbers, volumes of data, can grow quickly. Fact table examples: retail, number of units sold, sales amount. Telecommunication: length of the call in minutes, average calls. Okay, those are examples for fact tables. Types of schema: start schema, slow phase schema, axis schema, fact cancellation schema. These are different types of schemas available, and the star schemas star schema is one of the one which contains central fact table surrounded by denormalized dimension tables. A star schema can be simple or complex. A simple star schema consists of one fact table, whereas complex star schema have more than one fact table. This is a pictorial representation of star schema. Next, we will be discussing all this in detail later. So, slow phase schema. A slow phase schema is an enhancement of star schema by adding additional dimensions. Slow phase schema are useful when there are located attributes in the dimensions. Focus pictorial representation, galaxy schema, fact cancellation schema. Compound dimensions. A dimension table which is shared across data modes or more than one fact table is called as compound dimension. Okay. These are okay, and these are the slowly changing dimensions. SCD captures the changes which take place over a period of time. Type 1. Type 1 dimension keeps only the current values, doesn't maintain history. Okay, type 1 in SCD type 1 maintains the current values, it will not maintain the history. SCD type 2. Type 2 dimension maintains the full history in the target. For each update, it inserts a new record and the target table. SCD type 3. Type 2 dimension maintains current and previous information, partial history. It will not maintain the full history. Okay. These are the brief introduction of the Informatica tool, and moving on the testing part. ETL testing life cycle. See, in testing life cycle, it's like document activation and full function specific document, overall system design document, database design specification document, and data model diagrams. Prepare test plan. Next step is prepare test plan. Third next step is prepare test cases from source and target tables, record count of source and target tables, and ETL validation. Prepare QA environment and deploy the build script in QA environment. Next is prepare test data. Next is different types of testing: sanity testing, functional testing for all components, regression testing, integration, and end-to-end testing. QA sign-off, test summary reports, defect summary report, database script with deployment script, workflow build information, performance summary report. Software test life cycle: test planning, test analysis, and test design, test execution, and test closure. And in this, we will be having in test planning stage, we will be having test strategy and test plan. Test planning will be done. In test analysis, we will be preparing BRS and service study, and in test design, we will be preparing test scenarios and test cases, input output data, traceable metrics. In test execution, we will be executing the test cases and reporting the bugs and retesting. And test closure, test summary report. Okay. Test plan template. It's like the template for the test plan is like if you will be looking like this, which contains objectives, scope, in scope and features to be tested, types of testing applicable, out scope, approach, resources, schedules, entry criteria, exit criteria, deliverables, traceability metrics, and defects. Okay. Moving on, types of ETL testing. There are different types of testing which we will be carrying on in detail. There are constraints testing, where we will be testing the constraints on source and target tables. Source to target record count, where we will be testing the record count from source and target tables. Data validation testing, field to field testing, duplicate check testing, where we will be taking any duplicates available in the target tables. Exceptional data handling testing, log information testing, incremental and historical process testing, negative testing, and transformation testing, where we will be testing different types of transformations are working correctly or not, regression ETL testing, and ETL performance testing, and constraints testing. We'll be discussing all this in the later. Source and target records count testing, and these are different types of testing concepts available. And that's what the introduction ends for the ETL testing. Thanks for the thanks for the demo, and bye.